So the topics for this lecture is the wide-nose plier problem, and what we'll be discussing is how to assign the contact bodies to avoid solution errors that many of you have been having. After this lecture, it's important that you're able to assign the contact in your model to generate a more accurate solution. Of course, you want to get the homework and the participation done, and understand the importance of ordering and assigning the contact surfaces and parts and sets. That's the actual more important issue. What's going on and how do we fix it? So realize the solution to this problem is actually found by trial and error by one of the TAs, and I'll tell you who in a second. But some key features of what was corrected are that we reordered how we entered things into COMSOL and the ordering of those contact pairs, those upper and bottom boxes. There were some small notes to that in the lecture that actually led to the understanding of the solution of this problem. And these small notes actually came from some COMSOL tips, but you may have overlooked them, and sometimes they weren't needed, but sometimes this semester they are. The first is that noticing the jaw is actually larger than the fork, and COMSOL suggests putting the larger piece in what will be the lower box on this model. The other issue comes from the fact that the pins do not move. Therefore, it makes a good reference. The rationale for putting the larger piece then in the lower box works here as well. Something that is better suited to being a reference, meaning it's larger, meaning it's immobile, it doesn't move, meaning it's the one thing that connects to multiple other things. Those things should go in the lower box. And why should those things go in the lower box? Well, behind the scenes, there are a host of numerical algorithms going on to try and determine when these surfaces, which are all discretized by sets of points, come in contact with each other. It's actually a pretty tough computational problem, and the easier that we can make it on SOLIDWORKS, the better. One of the ways to make it easy is to let SOLIDWORKS have access to the things that are most likely to be simplest to solve all in the same place. How do we do that? COMSOL has told us you put the big things in the lower box. You put the references in the lower box. What that means is that in their solution algorithms, they're most likely trying to tie everything in the upper box to things in the lower box. Understand that the lower box is closer to our reference, and the upper box is the one that might move around. If we don't give it the problem in that fashion, it will have a harder time solving it. And some things will solve and some things won't. Oddly, small changes in your model may actually allow it to solve in some cases and not others, and changes in the background way the program runs, sometimes due to updates, can make something that once was solvable, but maybe barely so in a way that you didn't notice because it was behind the scenes, make it an intractable problem with a different set of conditions or with an upgrade. So, understanding that complex problems can have numerical vagaries that can lead them to be unable to find solutions, or even worse, to find erroneous solutions, is something that's important. Thinking through the underlying methodology in the simulation, then, is often key to working around those problems. And who do we have to thank for these solutions? Mr. Courjou was able to ferret out these issues within this model. If you have a chance, please thank him, either in class, in his sections, or over email, or on the discussion board. He's the one that went through and troubleshooted this for us and to figure out that the order in which you place these is what actually can make all of the difference. Okay, so how does this play out? Well, if you see here, we have the part. It's already made. We have the whole assembly, I should say. The loads are applied to it. Here, we've got our fixed condition on our pin. We have our fork, and then we've got the contact surfaces there, which you can kind of see a little bit highlighted. The issue here is that the fork face should be in the top, and then the jaw needs to be in the bottom. This can go along our basic COMSOL suggestion that the larger piece needs to be in the bottom box, and that makes the fork the smaller piece that goes in the top box. And if we can do that, then that will actually help us solve the problem. Alrighty, and now with respect to the jaw and the pin, what do we know? Well, the pin is the thing that's actually fixed. the jaws move around that, and so the pin then would go on our bottom face. Even though it's smaller, it's the one that's more of a reference because it doesn't move. And then we have the jaw faces in the top, so that the jaw faces can actually rotate around that pin. And it's a little bit heuristic. It's a little bit sort of understanding the logic of these things, and it's a little bit trial and error. When you have these problems that are really based on some complex numerical simulations, numerical procedures, especially when those are nonlinear, they can go off the rails for what seem like small things. But having an idea of how they're working can help us. So COMSOL tried to tell us, maybe we didn't listen well enough at the beginning, but bigger things, reference things in the bottom, smaller things, more mobile things at the top. And with this, he was able to generate the solution, and you can see the von Mises stress running from a low end of about, 3 times 10 to the second, up to a high end of about 3.7 times 10 to the fourth, all the way out in our fork. Hopefully you can get something similar. Only takes about 13 minutes. Some folks have asked how long should these simulations run, typically on the order of what you see in the lectures. And if it's starting to take a lot longer than that, that's usually a sign that there's some kind of error in the numerics. They're going off trying to find a solution that's either difficult to find or that's actually not there. Well, thank you for watching. Hopefully this will give you some heads up and some insight into how to solve these problems. Hopefully if you follow this ordering, this will work for you, given that everything else in the model that you set up matches what's in the tutorial, and you can get the solutions close to what Mr. Cuvier has actually come up with himself. If you're still having difficulty, again, reach out to the discussion boards and understand that, yeah, some of these things are tricky and some of them are nuanced, and the issue is to understand what's going on behind the scenes to help us set them up correctly, to help the software help us. Thanks, and take care.